Welcome to the 2026 Enterprise AI Platform Decision, Navigating Vertex, Bedrock, and Foundry. This is an executive briefing and architectural framework for CTOs who need to make a platform commitment this year. 3 major clouds, 3 distinct AI platforms, each with real strengths, real blind spots, and real consequences for your engineering org. By the end of this presentation, you will have the heuristics, the decision tree, and the architectural patterns to make a defensible, durable choice. Let's start with what is true in 2026. The baseline capabilities across all 3 platforms are essentially equal. Google Cloud Vertex AI, AWS Bedrock, and Azure AI Foundry all ship with cost and billing controls, data governance and RBAC, Agentic orchestration primitives, fine-tuning and low-RA adapter support, and access to the major model families, GPT, Claude, Gemini, Llama, Gemma, and Mistral. This parity is the most important strategic fact of 2026. The surface-level feature comparison will not make this decision for you. The choice relies entirely on how a platform integrates into your specific operational reality, your cloud footprint, your compliance posture, your developer workflow, and your model dependencies. Since baseline capabilities are equal, the real differentiators lie at the operational edges. 4 factors separate the platforms in practice. Developer experience, API-first building versus low-code sprawl. How fast can your engineers ship, debug, and iterate without fighting the platform? Economics, the gap between opaque provision throughput units and serverless pricing, and the 70% engineering TCO reality that token cost comparisons completely ignore. Ecosystem lock-in, the gravitational pull of your existing cloud footprint and the native integrations that come with it. And niche compliance, specialized regulatory advantages in FedRAMP, FIC, and EU data residency that are not interchangeable across platforms. These 4 edges are where the decision actually gets made. Google Cloud Vertex AI is the model-agnostic platform, the widest catalog, the cleanest agentic primitive, and the most open architecture. The unified pipeline ingests Gemini 1.5 Pro, Gemma 426B MoE, Claude 3 Opus, Llama 3.170B, and Mistral Large through a single API surface, outputting to managed endpoints and the agent development kit. 3 clear strengths. First, best-in-class model garden with direct access to Gemini and Gemma, plus managed endpoints for Claude, Llama, and Mistral. Second, unbeatable open-weight economics, Gemma 4268B MoE at 13 cents per million tokens. Third, the cleanest agentic primitive. The agent development kit offers a unified API-first surface that outpaces Bedrock agents on developer velocity. 2 weaknesses to know. Onboarding friction. Inconsistent documentation causes a real 6-week discoverability delay for new teams. And tangled billing. There is no clean way to isolate AI spend from general Google Cloud spend, which makes chargeback and budget governance painful. AWS Bedrock is the ecosystem native, the platform built for organizations already committed to AWS. The architecture is entirely VPC native. Bedrock runs inside your existing AWS account, behind your IAM policies, inside your private subnets, through your VPC endpoints. It uses the same Lambda functions, S3 buckets, and IAM roles your teams already manage. 3 strengths define it. Frictionless procurement. No new vendor, no new security review, no new compliance conversation. It inherits your existing IAM, VPC designs, and HIPAA. Anthropic native, near perfect parity with Anthropic's direct API, making Bedrock the definitive enterprise home for Claude. And strongest content filtering, Bedrock guardrails leads in out-of-the-box PII detection and injection mitigation. 3 weaknesses, narrower catalog, breadth limited primarily to Anthropic, Titan, Llama, and DeepSeek. Fragmented observability. Monitoring is split across CloudWatch, prompt flows, and evaluations, creating alert fatigue. And heavy fine-tuning overhead. Customization and agent orchestration are slower and heavier than Vertex. Azure AI Foundry is the Microsoft 365 integrator, the platform that wins on time to value for organizations already in the Microsoft stack. The architecture plugs directly into Teams, SharePoint, and Microsoft Graph through high-speed data streams. If your knowledge workers live in M365, Foundry delivers AI to them in days, not months. 3 strengths. Instant time to value. Plug directly into Teams, SharePoint, and Microsoft Graph in days. Exclusive model access. Foundry is the primary distribution point for GPT-5 and O-series models, You cannot get these anywhere else at the same latency and integration depth. And first-party MAI powerhouse. Proprietary models like MAI Thinking 1 reduce third-party model reliance and give Microsoft customers a hedge against OpenAI pricing changes. 2 weaknesses. Surface sprawl. The split between Copilot Studio and Foundry agents causes weeks of migration confusion for API-first teams. And opaque economics. Provision throughput unit pricing is expensive, difficult to model, and poorly documented. Now let's look at model access and exclusivity across all 3 platforms. Because model availability is a hard constraint that can eliminate a platform entirely before any other analysis begins. Vertex AI has native star-rated access to the full Google Gemini family and open-weight models, but reaches Claude only through a managed API, not native, and has no access to GPT. AWS Bedrock has near-perfect parity with Anthropic's direct Claude API. This is the best Claude integration available on any cloud, but it also has no GPT access, and Gemini is cross-cloud with a caution flag on latency and reliability. Azure AI Foundry has exclusive day 0 star access to GPT-5 and all low-series models. Claude is available through a 2025 partnership agreement. Gemini is again cross-cloud with caution. The strategic summary. Vertex dominates sheer breadth. Bedrock is the definitive home for Claude. Foundry dominates GPT and introduces high-efficiency MAI models. If your architecture has a non-negotiable model dependency, this matrix may make the decision for you right here. Now let's address the number 1 mistake enterprises make in this evaluation. Confusing token cost with total cost of ownership. The left side of this slide shows raw token economics. Vertex wins the rate card with Gemma 4 at 13 cents per million. Bedrock and Foundry are positioned in the 15 to 25 cent range for comparable frontier models. But the right side tells the real story. Over a 12-month enterprise deployment, per token inference cost represents only 30% of total spend. The remaining 70% is engineering time, DevOps maintenance, observability tooling, compliance friction, and integration overhead. The implication is stark. The platform with the lowest per token cost is rarely the cheapest. A platform that saves you 20% on inference, but costs you 6 weeks of onboarding friction and a fragmented observability stack will be more expensive by month 3. TCO is driven by DX and integration fit, not the rate card. Model your 12-month engineering burden before you model your token spend. Agentic orchestration is where the developer experience gap becomes impossible to ignore. Vertex AI, the clean API, uses the agent development kit and delivers the cleanest, most unified API-first surface available. Verdict: highest velocity, lowest friction for pure code teams without heavy MLOps overhead. Azure AI Foundry, the low-code sprawl, offers Copilot Studio versus Foundry agents, creating 2 parallel development surfaces. Verdict: sprawling for API-first developers, but dominant for low-code plug-and-play into the Microsoft 365 ecosystem. AWS Bedrock, the heavy lift, uses Bedrock Agents plus Agent Core. Verdict: technically capable but possesses the heaviest and slowest developer experience of the 3. Fine-tuning and agent orchestration require significantly more engineering setup time. For engineering-led organizations building autonomous agentic systems, the Vertex ADK wins on developer velocity. For M365 integrated business workflows, Foundry wins on integration reach. For cloud-native agentic workloads, Bedrock provides the deepest model integration despite the heavier DX. All 3 platforms ship the compliance baseline, SOC 2, ISO 27001, HIPAA-BA, and standard GDPR compliance. This is table stakes in 2026 and should not factor into your decision. What matters are the niche regulatory advantages that create hard lock-in for specific verticals. AWS Bedrock is the undisputed leader in FedRAMP certifications and U.S. government workloads. If your organization works with federal agencies or requires FedRAMP high authorization, Bedrock is effectively your only option. Azure AI Foundry dominates FI compliance combinations for highly regulated financial institutions and healthcare organizations. The combination of Microsoft's existing financial sector relationships and Foundry's audit trail depth makes it the default choice for U.S. banking and insurance. Google Cloud Vertex AI leads in European data residency and complex European public sector postures. If your organization operates under strict EU data sovereignty requirements, Vertex's regional isolation architecture is the strongest available. Compliance is not a tiebreaker. For regulated industries, it is often the only criterion that matters. Here is the strategic decision tree for Part 1. Cloud footprint and model dependencies. Start at Node 1. Is your enterprise 80% or more embedded in a single cloud provider? If yes, stop. Stay there. Adding a second cloud for AI triples your networking, observability, and compliance overhead. The switching cost almost never pays off. If no, proceed to Node 2. Is a specific model family central to your architecture, a non-negotiable dependency? If Gemini, select Vertex. Native access, best economics, cleanest integration. If GPT-5 or Microsoft 365 workflows, select Foundry. Exclusive day zero access and instant M365 integration. If Claude, select Bedrock. Near perfect API parity and the deepest Anthropic integration available on any cloud. If you are model agnostic, your architecture can swap model families without major refactoring. Proceed to Node 3. Node 3 asks about your MLOps stack. Do you have existing, mature MLOps tooling? Kubeflow, MLflow, Vertex pipelines, SageMaker? If yes, any of the three platforms will integrate. Your MLOps investment is not a differentiator here. If no, you are building MLOps from scratch alongside your AI platform. Proceed to Node 4, the compliance bar. Node 4, does your team have strict approved vendor lists driven by regulatory requirements? If Azure approved only, FIC, financial institutions, healthcare, select Foundry. If AWS approved only, FedRAMP US. Government, federal contractors, select Bedrock. If EU public sector regulated, data residency, GDPR sovereignty, select Vertex for its single surface data lifecycle management. If none of these compliance constraints apply, you have genuine optionality. Return to the operational edge analysis and choose based on developer experience and the model ecosystem matrix. Here is the unspoken reality of 2026 enterprise AI architecture. Almost no large organization will run a single platform. The production pattern that is emerging looks like this. A primary managed cloud, Azure Foundry or AWS Bedrock, handles 80% or more of standard AI workloads and all highly regulated data flows. A secondary managed cloud, typically Vertex, handles workloads requiring a specific non-negotiable model family that the primary platform does not support natively. And a self-hosted VLLM layer on GPU instances handles sustained high-throughput traffic using open-weight models, deployed where per token economics lose to raw GPU hour economics. A load balancer routes incoming traffic across all three tiers based on model requirement, latency, budget, and compliance classification. The strategic imperative: mitigate vendor lock-in and optimize for bursty versus sustained traffic by decoupling your workflow from a single managed endpoint. Design your abstraction layer now, before you are locked into one platform's agent framework. If you are beginning your platform evaluation today, here is the 12-week roadmap that produces a defensible decision. Weeks 1 and 2. Clarify requirements. Draft a strict one-page document with sign-off from product, engineering, and compliance. This document defines your non-negotiable model families, compliance constraints, and primary workload patterns. Do not proceed without it. Weeks 3 through 6. Parallel prototyping. Stand up the exact same use case, your actual production use case, not a toy example, on your two candidate platforms simultaneously. Measure real DX, real latency, real integration friction. Weeks 7 through 10. Cost modeling and procurement. Extrapolate 12-month TCO including hidden costs, engineering time, observability tooling, fine-tuning overhead, compliance audit burden. Run contract language past legal before you are in a time-pressured clause. Weeks 11 and 12. Pilot production. Deploy a limited live workload. Make a hard go or no-go decision before signing an enterprise discount agreement. Never sign an EDP without a live workload running on the platform first. 3 core strategic takeaways for 2026. 1. Do not pick a platform based on a polished vendor demo or mere per token cost. TCO is ultimately dictated by engineering friction and developer experience. The demo will never show you the 6-week onboarding delay or the fragmented observability stack. 2. Your existing cloud footprint is your strongest center of gravity. Deviating from it triples your network and compliance overhead. The math almost never works in favor of the greenfield platform switch. 3. The goal is not to pick the objectively best platform in a vacuum. The goal is to select the platform your engineering team will not regret maintaining at month 18. When the initial excitement has faded and the real operational burden becomes clear, make the decision your team can defend, operate, and extend. That is the 2026 Enterprise AI Platform decision.